be honest with you, we never expected
just in case. Good afternoon. Welcome to this afternoon's presentation regarding drone flights and highway design. My name is Chris James, and I'm the District 12 Design Section Supervisor for KYTC in District 12 in Pikeville. With me today is Tracy Wright. He is from the District 12 Survey Crew. Justin Reichenbach from the District 12 Design Office, and Tyler Mills from Lochner. John Hieronymus was going to be here with us today and wasn't able to come, but just wanted to mention him and Tyler both for their help with putting this presentation together, and then also for the technical expertise that they've lent to us on this subject. Just to give kind of a brief introduction of how the session is set up, we have it mainly in three particular portions. First, I guess mine would be probably the most simplistic of all, is generally an overview of what this topic covers. We'll be talking about what to expect with this session, and then also kind of giving an overview of the projects that came into the picture with this subject and how we applied some of this technology. Second, Tracy, Justin, and Tyler will be focusing on the technical aspects. So each of them have a particular portion that they'll be sharing information about, and they'll dive deeper into the details. And then finally, at the end of the session, we'll take any questions and try to provide some answers, and also any feedback that you may have about maybe some experiences that you've had relating to drone use. So we thought it would be helpful to have, just to give you an idea what to expect and also what not to expect with this session today. So first off, this may be a little backwards, but just what not to expect with this session is cutting edge technology use. Basically, the things that we used in doing this type of work on the highway project was equipment and software that we already had available to us. For the most part, this was just learning how to apply that in a particular situation, and also kind of building our skill set to the point where we felt comfortable with trusting the data. Second, we're not going to focus much on advanced tools and skills that are only for the elite. We are still learning in this process. We in District 12, and we leaned on Lochner with their expertise, but we don't look at ourselves as the most advanced users with this subject. So we're still learning. So hopefully from us learning, you can also learn a little bit as well. And then also the feeling that this might be available for use someday. We've kind of joked that we've probably all seen sessions where there's a new technology, a new software program that's introduced, and you don't really know when it's going to become available to you. It looks great, it's going to help with your processes, but it's just not there yet. All of the equipment and software that Justin and Tracy are specifically going to show today, that's all the stuff that we already have. So it's not like we went out and spent extra money to do this. So what to expect? So first off is that we're wanting to show a practical application on a typical highway design project. Now, typical is kind of a loaded word, I guess, because so many projects have their own unique characteristics. And one of the main ones that we'll discuss today also had some unique characteristics. But the main thing about this was, this is not the most expensive project. It's not the highest profile project, and it's not one that is necessarily larger than any other project. So these are things that you can see, hopefully, that you can apply in a lot of different applications. Second, we want to show some ways to learn about the tools that are available for use now. Like I said, we had to learn as we went with this to show how we could actually get data that was useful to our process. So those tools, like I said, they were already available. And then finally, this last portion, it doesn't necessarily just focus on drone use, but it's also just about how collaboration can expand your skill set. We collaborated with the folks with Lochner, and that allowed us to grow with how we can use these processes in ways that we had not done before. We had gotten our feet wet a little bit with it, but up until now, this is something that we haven't really tried to do. So having someone that we can lean on, who's been down this road a little bit before themselves, that allowed us to learn. So the region that we're going to focus on mainly with some of these projects is in northern Kentucky. And as most people in here know, that the northern Kentucky region is just exploding. It's just full of growth and a lot of opportunity. And with that growth comes a lot of transportation improvement that's necessary. So some of the projects that are ongoing in the area are the Boone County 6-444 and 6-445 Donaldson Road and Mineola Pike projects. Wagner is the prime consultant on this project, and they are providing services such as roadway design, visualization, NEPA documentation, public outreach, and bike facility design. A smaller project in the area that's ongoing is called the 6-8916 Houston Road Extension Project. This project was originally surveyed by GRW, but roadway design, geotech, and structure design is being provided by KYTC. We in District 12 are working with the roadway design portion of this, and it's been a learning experience for us just working in this area. It's pretty different for us. So the collaboration that I mentioned a little earlier came about because these two projects, the Donaldson Road project and the Houston Road project, come together at this intersection and overlap. So that led to an opportunity where we could each share information that would benefit the other parties. So we worked with Lochner and District 6 to figure out what information was available, file sharing, and so forth. And that helped to begin this early stage of the relationships that we had working with Lochner. They were very responsive in giving us information, willing to help where they could, and we tried to do the same for their project. So as we were working on the Houston Road project, another job came about that we became involved with, and that's the Boone County 6-80150 Turfway Road project. And as you can see, it's just to the west of the interstate, and just barely to the east of the airport. It begins to at south end at the Kentucky 1017 Arrow Parkway intersection, and then ends at the north with Donaldson Road. So as we began to work on this, we began to kind of gather our thoughts and try to think about what information was available and how do we go about building a data set that we could use for preliminary design. Well, one of the things that came about with this was Wagner had already been working on portions of Turfway Road, especially where it intersects Donaldson, because part of Turfway would be affected with that project. We also began talking to our District 12 survey crew, and that's Tracy Wright, Tim Holbrook, and Mike Brown, so that we could figure out what challenges would we have with this project, what kind of issues on the ground would we need to watch for, and what data in particular would be something we needed to focus on. As you can see, the airport again was just to the west, so that was something that was going to come into play as we began to collect this data. So after we got our thoughts together, we came up with this approximate survey limit map, and then we turned it over to the survey crew, and they began to figure out how would they go about collecting this data. So with that, I'll turn it over to Tracy, and he'll walk us through that process.
Yes, I'm Tracy Wright. I'm with the Survey Crew District 12. This is one of the problems that came up with this job was the fact that it's a District 6. We're District 12 driving out of East Kentucky, and we're trying to make the most bang for our buck every day we're on the field to make sure that we can have a product that is deliverable to our designers to be able to create a working template and service that we can use. So we had a lot of obstacles to overcome. So we decided to go out and start out essentially using with our 3 essential tools that we usually on most every project, and that's our conventional surveying, our terrestrial scanning, and drone flight. That's something that we use typically on almost every project. It's hard to find one that we haven't scanned or flown in the last couple of years. And so it's become something that's essential to us to create a great large data set that we can use and go back to, maybe a year down the road. Just the emphasis on the Donaldson Road or Houston Road section was, I think we went out and scanned it, 18 months ago, something like that. Me and Justin went out and scanned it, and just probably 2 months ago, Chris had asked about a curb line that wasn't picked up by GRW because it wasn't existent at the time when they initially surveyed it. So I was able to just open up a point cloud in TBC and select those curb lines and gutters and be able to extract that so he could add to his plans. It's something that was that was essentially 3.5 hours away from our office that we was able to pick up, and I was able to give him something to deliver in 15 minutes. So there's benefits to using a point cloud and to drone work and to our conventional surveys where they don't have to be just one or the other, but they can be married together and used in every project. There's nothing wrong with having too much data. It's always something we can go back to. We want to make sure that we're using our data sets. We had a question earlier asking about doing the data sets and keeping them as one large set. I prefer to work at them as individuals, to create the conventional survey terrain as its own. My terrestrial scanning, I want to keep it separate, and my UAV separate. Then I'll merge them together in ORD to make one complex terrain that I use. But I want to use each individual one. That way I can see the problems when I put them together. I can see if there's anything different, anything changing. And it may be some, cover some steps to go through, but I can actually use the checks and balance that I kind of use to prove our findings with whatever we're doing different processes, different means. This is just our a sample screenshot of our parent terrain that we're going to use, and that was with our GPS location. We just went out and done the typical, just walk the pavement, shoot the gutter lines, curb, any the lane lines, things like that, that were just something that essentially that would be time consuming for us to go out and create in our point cloud. We just went ahead and done that with our GPS. It took us a day to go out and shoot this, and it was something that we knew that we was confident that we could use as our parent terrain to be able to tie everything to, that we knew the accuracy was going to be there what we want. Our second step was to go ahead and scan this this project. This is a SX10. It's a robotic tilt station. It does you can use it as a robot to use your just regular conventional work, or you could use it as a total state or a scanner that we can go ahead and scan this room. I think the range on it's like 1,200 feet, something like that range for the shot. So I mean, I've checked these things out by checking the shots out to try to stake out to them, and I'm getting pretty good, from that range. So we use this to for other obstacles, keep us out of the traffic line, maybe out of a creek. As you can see here, we actually scanned this in one day, and it kept us from having to be down next to that creek on that slope. We were able to pick up what we needed from there with just a simple scan. From this, we had about 24 setups in this project, which took about 12 minutes for each setup, so it's a little time consuming on that part. But we had a huge data set with 120 million points. Now, most of us in this room don't have a computer that can handle 120 million points to put triangles to and be able to open up and work with. So we had to find a way to use TVC to go ahead and process this and get it down to a working, usable data set. So we just went ahead and sampled it down and classified this data set. Then we can go ahead and you look at the point cloud, and you can see all the stuff that's here with our telephone poles, a fence line, all these different data points are there that we can create a CSV file from, and to be able to export and create a train from at any point along the process of the project. We talked about classifying the point cloud. This is just a classified point cloud of that section. You can see the vegetation, the power lines, the power poles, just different things. The brown is actually the ground surface. Those are all, this is what the algorithm does in the software. It's just simple, just classify point cloud, and it does it automatically. There's a tree extraction also in the software that's pretty handy. This is the same image with just the high vegetation turned off. So you can see all the different things that we can look at and use to sample out. We've already cut down the point cloud size. We went from that 120 million points down to possibly in that probably 60, 70 million shots just by turning off some of the things that's not needed. So when I get to this point, I usually leave the ground surface on, and I just turn everything else off and look at the ground, and I'll start cleaning up a point cloud. I want to clean it up to where it's something that's usable and clean from, because the algorithm can make mistakes. There is things that may get classified as trees or buildings that may be actual ground, but you have to go in and actually change that around and take it out and cut it out yourself, just by using the edgy tools. So once I got to that point, I went ahead and created this section. I sampled down the ground to like every 5 feet, and then cut it down to a usable size that is like 100,000 points, I think, on the terrestrial scan. They cut it down, extracted 100,000 points in that range, and cut it down to that much. I think it's like 2%, something like that, what I was going to actually look from. So that, as you can see, it's still a large data set of information that we could use and carry over. So every 5 feet is way more than I'm going to survey. I'm not gonna give you the detail every 5 feet I go to survey that line. So at that point, when we got to this point, we were still having our terrestrial scan and our GPS work that we had done, and we had exported these terrains to be able to go to. We still needed some areas that were still hard to get to. There were still some places that we had a swamp land. We actually had this property that was just inaccessible because it was a fill area, and we wanted to get more detail because when you go to a line and grade meeting, things can always change. 50 feet on an alignment makes a big difference in what you're going to impact. We want to make sure we have enough coverage to add that into our terrain that we can actually use from and not have to be going back out to the field. So that's when I turned it over to Justin to have him come up and describe what we done in the process to do our drone flight.
Heard the people online had problems here, which I'm going to try to stand still. That's the problem. Why use drone? These are the reasons that I think is most important for what we're doing in this area. I like to have the most up-to-date aerial imagery, zero reference, so I can pull it straight into a plan sheet, straight to an exhibit, straight to a strip map. And I can also at the same time supplement the terrain that Tracy's already got through conventional and terrestrial methods. The area in question here, a large part of it was marshy, hard to traverse on foot, rocky. So in the total 30 minutes it took to do this flight, I was able to cover 72 acres and gather everything we need. What to fly? Tracy and Chris and I got together and we realized we would benefit the most from getting an aerial survey of the area inside the Scalability. So I took that KML that I made in Google with that boundary, pulled it into my controller from a FEM4 RTK drone, that DJI drone. Edged it for 200 feet of elevation, that's what we chose to try to fly. Just my horizontal and vertical overlap to 75, some people use 70, some people use 80, just personal preference, worked out great in the situation. But the most important setting that will come in later is this margin setting at the bottom on the right. And I set it to manual, and I actually set it to 0 meters. That ensures that my drone will not fly outside the boundary. And since we're in close proximity to Cincinnati Airport, which is Class B airspace, controlled from 0 to 10,000 feet MSL, I didn't want the FAA out on us. Now, we already know why we want to fly. We know where we're going to fly. Now I need to know, can I do it? Because this is new to me. I mean, I've had my Part 107 since March of 2019, and this is the first time we've ever into this. So I went to the FAA airspace, the facility map. On the left there in the center of that circle is where we're at. You'll see a set of elevations in red. You got 0 feet, 200 feet, 100 feet, 400 feet. We are in the middle of a quad with a 0 foot, which means I'm going to have further safety analysis from the FAA. Went to the FAA's webpage, logged into my account, gave them all the information they need for a project, how high we wanted to fly. 6 days later, I get my approval, 6 business days later, I get my approval for the flight in Class B airspace, 200 feet AGM. These were the exhibits they provided to us. They gave us the boundary in green on the right that we had to stay inside of, and they had lab lungs associated with it. So I had to go back to my controller, update my KML with the new coordinates. But even with this authorization, the drone wouldn't take off the ground unless I went to DJI's webpage and make the drone, because it's got a no-fly zone built into it. I had to fill out and apply for a custom and self unlocks, which it only took about an hour to 2 hours to get that approved. So we're 6 days in on the authorization from the FAA, and maybe an hour or 2 in for that. Called air traffic control 15 minutes before the flight. Let them know we're going to be in the area, and Tracy and I will be able to take off. 30 minutes later, landed, produced 558 geotag images, which I was able to couple with his CSV file using the photogravity methodology in Pix4D. I was able to process this, provide Tracy with an LAS file and a georeference aerial image of the flight, which he could use to supplement his terrestrial and conventional surveys. And this is just a point cloud straight off Pix 4D, 3D point cloud. To give you an idea of what it looked like when I finished.
If you notice on this slide here, it's good to point out just, our limits, we're not flying on traffic. And with our overlap and the angle of what we were flying at, we were able to cover over and actually get a lot of the highway. We're not all the way across, but some places we got good coverage. And the thing that I do like to use with our point clouds, and we talked about earlier, was to be able to have a check and balance with it. And I'm looking for my point cloud to see how my surfaces match on the hard surface of the pavement. And when I was actually checking this with our parent control from our GPS work, and then with our terrestrial scanner, we really come to a conclusion that it was really tight for the work we're doing, considering we're using photogrammetry, terrestrial scanning with a laser scanner, and GPS work. So we're really hitting in a good measure. We felt like we had a good product, and I think it shows this is exactly what we did. I mean, 70 plus acres of coverage in 30-minute flight. It's just amazing. So we're going to take this LES that Justin has provided me, and I'm just going to drag and drop it into TBC, Trimble Business Center. You guys may not have never used it. It's just this drag and drop method. I just grab the LES and open it up into an open project, and I'm able to classify and do all the processes I've done with the terrestrial scan. I'm able to classify and turn off what I don't need, what I do need, and sample it down all the same process we've done before. As you can see, as we sample down, we've got the vegetation, the buildings. You notice how the way it classifies the buildings on the side, the staples over here near Turfway. We have just the different things that it classifies, but you also got to remember that it's not perfect. You can always try to reclassify, to try to sample down and make it better. You can do it. It's just going to keep working at it. But it's eventually going to get to the point where it says, okay, I'm telling you this is a building, and you're telling me it's not. But so it goes down to a certain point where you're going to have to manually go in and start working on these things and try to work on it. Understand the time behind it to make it work. But at the end of the day, I was able to take this surface and left just the ground on and sample down to 5 feet. And that's something that I want to leave to know that you can adjust that for your sampling size to whatever you need. Don't think that it's just because you've seen 5 feet or 2 feet or whatever. It's whatever works for you to get what the end result, what you're looking for. Know that that point cloud is still there. You're not deleting anything. You're just using to create your surface from. You're going to sample it down to a more usable surface. You can always turn things back on and go back to where it started. As you can see, we extracted down. We extracted 68,000 points. This estimated there 68,112 that we was able to take over and use for our surface. And once we got that surface, we just exported land XML, which has been the easiest format that I found to just take out of the TDC. And I was able to take over and merge those into our parent terrain that we use from our GPS work. And it came with a great model. I felt really great about it with the end result. And then I was able just to take this file, and I was able to send this DGN over to Tyler. And Tyler at Lochner, he was able to take this model and use everything that he got from the LAS from Pix 4D and drop it into context capture to show our next part of this presentation. I think that it really shows us how easy it is for us to actually work together, because most of these files were shared through Teams or no large servers, that we were using, transfer back and forth. And that's something that in this day and time, we got to keep open mind how we're going to get the job done. And sharing large files and getting things out seems to be a little cooperative way. So I'll turn it over to Tyler this point.
Hello, my name is Tyler Mills. I'm a roadway designer with Lochner. I started off as just a little background. My EIT years, I was in District 7 design, and then I've been with Lochner now for about 4 years. And I've had my Part 107 for just over a year now. So as Tracy and Justin have gone through their process, they're showing how pairing traditional ground GPS with terrestrial scanning and data from a UAV photogrammetry process. in our office in Lochner, myself, John Hieronymus, and Troy Woodyard, for the last few years, we've been working with aerial photography and Bentley context capture to produce some 3D meshes and to add for various different tasks for our projects over the last few years. A lot focusing in public involvement and communicating with major stakeholders, as well as the right-of-way process, and then even into the conceptual design, like before the project. So I felt like this was a good opportunity. This was a great collaboration opportunity with D12 to take some of the process we've been looking at, just aerial photography, and what we were trying to do was, see how accurate this stuff it was a good test to see how accurate the stuff we were doing compared, stacked all the tools that they had at their disposal. So what I wanted to touch on is how we've used context capture. And I took their drone images and just some of the ground control points, and I'll show that in a little bit, to create 3D meshes. And all of this is within the Bentley environment that we're all using. And one part of this is that it interacts so well with ORD and everything else. So I'm gonna talk a little bit about that. This is just a screenshot from context capture and a couple of the keywords from the process. So Justin mentioned Pix4D earlier. If anybody, I've talked to other people in the cabinet. It seems that Pix4D is being used as another option for photogrammetry. So context capture is similar. Just one of the main differences is it's in the Bentley workspace. So there's certain options that make it play nicer with the Bentley workflow. As far as comparing the terrains, this is Tracy's final complex terrain file, his triangles and his line work with the 3D mesh that I exported using just Justin's aerial photos, just the photos, and 6 ground control points. And this is a screenshot out of ORD. So comparing these, this photorealistic 3D mesh with their complex terrain, we're pretty happy with the results. As you can see, we've got our control point boundary here, and we had 4 shots from the field that we used as a test to compare the model versus GPS. And, this is a flight from about 200 feet above the ground. It took about 30 minutes for the flight. And it's also, as a reminder, this is just using a 1-inch camera sensor on the drone. This isn't a LiDAR scanner. This isn't any kind of aerial scanner. You're literally just using the photos taken from the drone at 200 feet. And within the control boundary, we're finding an accuracy of around 3 centimeters compared to the terrain that Tracy had developed, which we're pretty happy about. Now, one of the drawbacks I wanted to mention with photogrammetry, anybody who's ever worked with it, when you get into areas of thick canopy or dense vegetation, as you can imagine, the drone's looking straight down. If it just sees the top of a tree, it's not going to catch any of the ground. So just like Tracy was saying, there's different tools. So it's critical when you're going into a project of understanding the terrain you're going to go into and which tools you're going to need. So while a lot of this data through here, we felt pretty good about, there's some areas with the thicker vegetation that if we needed that data, there'd probably be a hole there unless we were to take some sort of other approach of finding a way to get a drone under the canopy or taking some kind of ground GPS measurement. So as a comparison of another way we've used this at Lochner, this is a smaller sample size in a lower flight. One thing we wanted to do, I was talking about checking against accuracy, is I think we really got to, or at least when I came in with Lochner on the process, we were using it more as a visualization tool at the time for the particular project. So then as we've progressed, we wanted to dig down and see just how much accuracy we could really pull out of this. So, while Bentley was telling us the software was really accurate, you're all good as any, I guess, practical engineer, maybe just stubborn, hard-headed engineer, we wanted to really put it to the test ourselves. So we did this pilot where we teamed with some surveyors from CDI. They went out into the field picked us out some control points and a couple test points. These are screenshots from the 3D mesh we produced. They picked up their control points on easily identifiable features like gas valve caps, and they marked spots on manhole covers. Again, understanding what the project needs. We picked these points on purpose so that we knew there would be no obstruction from the air. Looking down, I'd be able to easily identify these. I flew this at about 75 feet, so it was a little lower. But it was also with a DJI Mavic Air 2 at the time, which, it's a smaller camera sensor. So again, this is a half-inch camera sensor. So an even less powerful form of technology, but the way we're able to use it and process it, we're able to get really nice results out of it. So as far as the data here, we were pretty happy with the results within the control boundary, 0.3, there in the middle of the road. The accuracy there compared to the survey points we were provided with, it was within about 1.5 centimeters horizontally and vertically. Points 1 and 2, just outside of that, we're still within 2 to 4 centimeters. And we wanted to, about 150 feet, this 0.4 is where it starts vertically to the photogrammetry software. You got to guide it a little more. We were trying to figure out exactly where the limits were, how far you could push it. So we found that about 150 feet out, but even still, this was within like 3 inches vertically, which was much more accurate than the other data sources that we had on hand. So it was useful information to have still. And like I said, this is using the Bentley environment, so we're easily able to bring all this directly into ORD, manipulate and compare it. So, this 3D mesh has, like Tracy was saying, a lot of these have just a massive amount of points. So, but using ORD, it's one of the file format is a scalable mesh using context capture. So it'll automatically adjust the density of those points when you're trying to view it. So that helps your system a little bit, but you're also able to take it into ORD and like Tracy was saying, you use 5-foot sample size. You can adjust sample size and pull out a terrain from this mesh. So you have a photorealistic mesh that you can use for communication purposes and to check validity and really get a clear picture of the project. But then you can go ahead and pull it out and have your more traditional triangles, terrain, and however you best need to work with it. So in this cross-section view, we have all the data that we had available for this area to compare. This point was the survey point provided from the GPS. The top surface was from our terrain that we produced in context capture. And down here was the KY raster LiDAR that was in the area. So this was a point that was on a manhole cover in the middle of the road. And the LiDAR was still coming in within, under 1/2 foot or to a foot along the road. But it was really when you get about the extents, outside the extents of the asphalt, and you had any kind of obstruction or cars or anything that could have been in the road. The terrain that we were able to get from the aerial photography was much more reliable. So to talk a little bit about scalability, this is on the upper end. So that was a smaller scale example, and this is a larger that we produced for visualization purposes primarily. This is a project just south of Knoxville for TDOT. The existing was all produced from aerial photography and context capture, and the proposed model was we modeled it in. I think at the time it was still SS2 because it's been a few years now, but we pulled all of that into OpenRoots to be able to combine it and create these visualizations for then the client to then take and use to discuss the project with the major stakeholders and in their right-of-way negotiation processes. So when you have all these tools already, like if you're pulling this information in on the beginning of your project to use with the survey, you already have it at your disposal if you need this type of tool later on in the project. So if you're using this for survey, then it's much easier to turn around and produce something like this if you're finding you need some kind of extra tool for public involvement or right-of-way negotiations, or even just communicating amongst the project team. So to conclude, we found that drone imagery can really be used in so many different aspects of the highway design project process today. Like Chris said at the top, we weren't trying to, go out and make any kind of like large new investment. We're trying to use tools already at our disposal that we'd already been using and just trying to find new ways to use it and improve our processes. And if you're familiar at all with this area, over here on the left, this is the Turfway Road, the 3D mesh that I got from Justin's. And, this curve had a revision done within just the last few years. It was a 90-degree curve, and it literally, I think it was part of the same asphalt as the service road that the airport used. It was connected. There was just a gate. So through the traditional ways that they would usually get, something like Google Earth hadn't even, when they were starting to look at this, Google Earth still didn't have the updated imagery. So by just applying it and producing the imagery, they were able to get the up-to-date information that was critical when they were looking into it. We found a lot of uses to come out of these highly detailed 3D meshes, that you can pull straight into open roads, you can snap to them, and even with just a few ground control points, you could really tie those in and have geospatially accurate meshes. And then down the road, you have massive potential for any kind of visualization that you need to later on communicate the project. So that's what we got. So anybody have any questions? Yeah.
So I guess the neighborhood, the smaller, data set you use, when you compared it to the Kentucky raster LiDAR, were the point controls used, the control points used to adjust that, the Kentucky raster LiDAR, or was it just simply bringing it in Kentucky raster LiDAR?
We just pulled it straight from the raster. So straight from the dial-up tool. So, but we were finding it wasn't where they were different. It wasn't consistent. It wasn't like a consistent below or above. So tying it in, it might have pulled some of it closer, but there were still a lot of inconsistencies that and maybe we could have taken that, classified it, cleaned it up some more, and still, but yeah. So we just took it pure from the source.
Yeah, I'm not very familiar. I mean, this is an awesome, it's awesome software, and I'm not fairly familiar, with all the capabilities. But I guess can you kind of talk about they went out and did the ground survey, and then you got the control points, and you also did the scan and got the aerial imagery. You talk about parent, and you're merging everything together. Can you kind of go through, briefly the process of how you work these together and adjust them using the control points?
Sure. Yeah. So, as Tracy described, he went out with the ground survey. He said he used that as his parent terrain, and then used his terrestrial scanning and the UAV to pull, match it to pull it into
All of
the
it was
parent
off the
terrain.
same control. So we,
Yeah.
the flight, the scan, GPS, all of it was using the same control module. So the surfaces were different. We used it from different tools, but they're all off the same grid. So we're bringing them off the same control points and using them to keep us on the same plane.
And so you just tell PPC, if you're a MI6 or 12 or how many other control points, and then it adjusts them based on.
Well, yeah,
So you talking about
Like a
context
photo-
capture, fixed 4D, like a fixed 4D, I pull in those 558 pictures, I pull in his control file, and then I go through and goes through about 3 to 5 pictures for each control point, and it actually makes you put a little dot right in the middle of wherever that control point was shot at, and then you run it through, and then it comes back and pulls all the pictures automatically based on their geotech references, and then I tweak as many as it puts on for each point. And that's how I think I got a ground sampling distance of 0.74 inches, so 3/4 of an inch per pixel. I mean, that's amazing. So,
Yeah.
And then what he does is even more amazing.
So all the white dots are all of the image locations from the geotag that's on the image. And then, so like what Justin said, I then went in and I found this control points in, I think I found it in 6 to 7 images, manually told it, zoomed in on the pixel, selected the control point, and then the software ties it all to that.
I mean, it amazes me, I mean, we're talking about, the aerial versus the other, and we're looking at, a half an inch, tolerance we build. It's just, you typically don't build within that tolerance. It's just, it's amazing how far the software, the technology has come.
Yeah.
Garbage in, garbage out. So if you start with a poor surface, you can get a poor
That's right.
job. And it's just, it's going to improve the process overall.
Yeah.
Thank you for sharing.
No, good question.
So when you planed your flight, did you speak 4D as well to set up your grid?
No, I didn't, if like a Mavic 2 Pro I have, I can actually use Pix4D, capture, I believe it's called,
Yes.
on my phone, and I can play it that way, but this controller for this Phantom 4 RTK has the built-in screen on it, and you're kind of, there's probably a way of side loading it, but I don't know how to do it, so I just used all the screenshots I was showing straight off my controller, and you can pick it, and pretty easy, really.
Yeah, so, for this flight, this was, like I said, I used the Mavic Air 2, and it has no third-party support. So this was like manual flight for myself, but now I'm using the Phantom 4 Pro, and it's, I can program it in, but depending on what you need to capture, like if I'm trying to get under a canopy to capture the ground, I'll still manually fly that so that I'm not, accidentally programming it to run into a tree or something like that. But so it all just depends on what you're trying to figure out. Yeah, I hit go and well, it went. That's where I told it to go. I have an old aerial, I guess. So the tree wasn't that big.
I just went over a tree.
Any other questions? One quick thing, one of the questions we had before was like liability, and Justin and I, we have the Part 107 certificate from the FAA, and it's commonplace if you're worried about it, you can pretty easily pick up like $1 to $2 million of liability insurance for flights, or there's those options out there too. But other than that, that's all. Thank you all so much.
Was I going in there?